All right, now I want to talk about how to change the order of integration. Sometimes because one way is easier than the other. Or in some cases, one way is impossible and the other one's possible. All right, so 0 to negative 1/2 x plus 1, 2 minus x minus 2y dy dx. Let's say you have this integral and you want to change dy dx into dx dy. What do? Here's what you do. First, you have to draw the domain, what your domain of the integral. So you have, if you have, this should be thought as y equal to 0. So if you have y equal to 0, and y equal to 1/2 x plus 1, which is this line here. Y-intercept is 1, negative 1/2 is the slope, and therefore the x-intercept is 2. So you start from this line, y equal to 0, to y equals to negative 1/2 x plus 1, where the x margins are from 0 to 2. So that's where x comma y is moving. The x comma y is moving inside this triangle. And while you're moving inside this triangle, you're trying to find the height times area element. Often this is written as dA, so that you get very small, very thin columns, and if you add them up, you get the volume under the graph of this function. Okay? That's what it is. Now, if you want to change this into dx dy, if you want to change this into dx times dy, 2 minus x minus 2y, then first of all, you realize that if this dx is here, you would be writing, anything that you write here has the meaning x equal to something. Okay? And now the outside should have a number. Now, the most common mistake is a lot of students who did not study a thing and they try to take the exam, when I ask how do you change this into that, they merely change these into these two switched. And that's really wrong. That's like zero credit. You get no partial credit at all, okay, if you just simply switch these two around. Okay? You really need to put it into this form where it's from one curve to another curve. It's curve to curve, and then point to point. Okay? So let me explain what I meant by that. When you have dx inside, it means you're trying to paint this region rightwards. When you do that, you start from this curve and you end at that curve. These are lines, but I'm calling them as curves, but because usually you start from something to something. In general, these are curves, right? So you start from this line and you end at that line. Okay. And therefore, if I want to know what to put here and there, I need to know the equation of this line and that line, because this is where I begin and that's where I end. Okay? Now, can you tell me the equation of this one?
Y equals 0.
Vertical lines have what kind of formula? X equal to number, and actually it's x equal to 0. So this is x equal to 0. Now, what's the equation of this line? Yes, this is y equals to negative 1/2 x plus 1. That's where we got the graph. This meant that. However, this is not fit for placing it here, because that one says x equal to. So what do? We have to solve in terms of x. So we're going to do this. Subtract 1, so that y minus 1 is negative 1/2 x. And I'm going to multiply by negative 2, so you get negative 2y plus 2 equal to x. Okay? And that gives you negative 2y plus 2 as where you end. X equal to 0 is where you begin. Okay? And you're trying to paint right words where you begin here and you end there. Okay? And then, what's the minimum value of y? And what's the maximum value of y?
0 or 1.
You get 0. Okay. That's how you change. And to demonstrate that this really gives you the same value as this one, we can actually calculate it, right? If we calculate it and we compute it and we get the same value as this, then you can believe that that's actually the correct way to do it, right? So let's do it. Remember, we did this calculation and we got what value for this interval? What was the value of this interval?
2/3.
2/3, right? We got 2/3. So let's verify that this indeed gives us 2/3. Now we have to integrate by x, so it's 2x minus 1/2 x squared minus 2xy. See, y is considered as a constant, so if you integrate 2y by x, it's 2xy. And then you're plugging in negative 2y plus 2 and 0 for x and y, 0 to 1 dy. And then these are values of x, so those have to go into x. When this is put in here, this is twice of that, so it's negative 4y plus 4 minus 1/2. X is negative 2y plus 2. And then when this goes in here, let's see, that's negative 2 times negative 2y plus 2 times y. Integrate from 0 to 1 dy. Let's see. That's negative 4y plus 4. If you square, that's minus 1/2. 4y squared minus 8y plus 4. If you compute the square of negative 2y is 4y squared, and square of 2 is 4. And you get some cross terms when you FOIL them out. That's where you get negative 8y. And then when you multiply this, negative 2 times negative 2, that's positive 4. So it will be 4y squared plus 4y squared. And then when you multiply this times that, that's negative 4y. Okay, let's simplify this further. 0 to 1. Negative 4y plus 4 minus 2y squared plus 4y minus 2 plus 4y squared minus 4y. Okay. Now do some things cancel? I guess these two cancel. And let's see what we have. 0 to 1. 4y squared minus 2y squared, that's 2y squared. And then negative 4y.
Wouldn't it be
Yes?
never mind.
And then 4 minus 2 is 2, plus 2. So that gives you 2/3 y cubed minus 2y squared plus 2y. And you're plugging in 1 and 0. When you plug in 1, these two cancel, and you get exactly 2/3. When you plug in 0, you don't get anything, so this is just 2/3, which agrees with our previous calculation. So it's exactly the same. So that's how you change the order of integration.